So a general parallelogram, what I want you to draw in is going to look like this. And then look at the first two properties. It's saying the opposite sides are, both pair of opposite sides are, wait, what did I do here? You gotta stop me. Are parallel. This should just say both pair of opposite sides are parallel for number one. That was weird. So to show that they're parallel, we use little arrows. So put a single arrow here and a single arrow here. That indicates that those two sides are parallel to each other. And then put double arrows for these two sides. That would indicate that those two sides are parallel to each other. Both pair of opposite sides are congruent, so that's when we use tick marks. So put a single tick here and a single tick here. That means those two sides are congruent. And then put double ticks here and here. That means those two sides are congruent. So that's old ideas. And then if you remember last year, you talked about rectangles, squares, rhombuses. Remember all those words? Isn't a rectangle also a parallelogram then, based upon what we've just talked about? These are parallel to each other. These are parallel to each other. Opposite sides are congruent. So you have this little flow chart. We will be getting into that a little bit. But there's a lot of different types of parallelograms. What we're going to talk about is that one first. All right, so in the next thing, these you would not have talked about last year. This is both pair of opposite. Let me write the word just so we have this, especially my bad writing on the computer. Both pair of opposite angles are congruent. So think about what that means. If I label this angle 1, angle 2, angle 3, angle 4, angle 1 should be congruent to the angle that is opposite of angle 1. Opposite meaning across from it. So if we look at that, hopefully we would understand angle 1, the angle that's opposite of it, that's across from it, would be angle 3. So opposite angles are congruent. So we'll put a single arc here. And then angle 2, so double arc angle 2, its opposite angle is angle 4. Those would be congruent to each other. If you just look at your graph, visually, that should seem reasonable. Okay, you can kind of see that. Number 4, consecutive angles. So consecutive angles. And like a lot of the stuff we've been doing, they're either congruent or supplementary. Same here. Consecutive angles are supplementary. So if we were looking at my diagram, so depending on how much you have drawn this in yourself, but if you look at my diagram, what that would mean is angle 1 plus consecutive means the angle next to it. So angle 1 is right next to angle 2. Angle 1 and angle 2 should add up to be 180 degrees. However, isn't angle 1 also consecutive or next to angle 4? So angle 4 and angle 1 would also be 180. So there's different combinations. 2 and 3 are consecutive. 3 and 4 are consecutive. So when we add an angle with an angle right next to it, they should add up to be 180 degrees. Okay. And then the last one. This you did talk about a little bit last year. You would have talked about diagonals. Your diagonals, this you would not have talked about, but you did talk about diagonals. Diagonals bisect each other. Since my diagram up there is getting kind of messy, let me draw in another little one here. All right, thanks, Gavin. Remember, diagonals connect the vertex. So let's go to this corner here, this vertex, to an opposite angle. So that's one diagonal. But we could also draw in a diagonal from here to the other opposite angle. That's a diagonal. They connect opposite vertices, is what you would have talked about last year with the diagonals. Those should be bisecting each other. So what that would mean is this segment here and this segment here would end up getting cut right in, or would end up being congruent because the overall segment got cut in half. And then since the longer one gets cut in half, that means this part would have to be congruent to this part. So this point right here is the midpoint for both of your diagonals when they intersect. 1 and 2 you would have talked about last year. We did not talk about angles in Math 1. 3 and 4 now start talking about angles. And then you talked a little bit about diagonals, but not the idea that they bisect each other. Okay? So with all of that in mind, let's have all of these right above on your paper, and let's fill these in. So it says, given that HJKL is a parallelogram, that means it satisfies those 4 or 5 properties that we just wrote down. Answer the following questions. So do the first one. Do the first 2, because the first 2 should be really nice and simple. This is, again, your parallel symbol. So when you see 2 lines like this, that's your parallel symbol. Normally they're like this, but it's hard to draw in Word to make them slanted like that. So the first one is just saying JK, that segment is parallel to what? And then LK is congruent to what? All right, I guess people to call on in here. All right, Cam, what do you got, Cam? Segment JK. So where's JK? So here's JK is parallel to what segment? Good. Segment HL, make sure you put the correct little notation over the top, aligned with no arrows on it. 2, L, so let's mark that then as well. So let's get used to our new markings for our diagrams. Come on. There you go. So parallel, we use arrows. These 2 sides are parallel to each other. All right, then segment LK. Where's LK? All right, so LK is down here. Ella, LK is congruent to what segment? Good. The opposite side of that is HJ. In a parallelogram, opposite sides are congruent and parallel, so HJ has to be congruent to LK. All right, so those are the nice ones. Opposite sides are parallel, opposite sides are congruent. So if we're going to mark that, we'll put little tick marks here. We could mark a lot more, but we'll go with just the ones that we have listed now. So number 3. Now the angles. This is somewhat new to this year. Angle LHJ. So again, just follow the little roadmap between all of those. So here's L. I'm going to go to H, and then I'm going to come over here to J. So it's this big angle H. So this big angle right here is congruent to, so if we look at our 5 properties listed above, the one that this is dealing with, if we're talking about congruency of an angle, is number 3. Both pair of opposite angles are congruent. So if I'm looking to see which angle this bigger angle is congruent to, it's its opposite angle. This would have to be its opposite angle over here. We cannot just call this angle K because there's an angle here with K, there's an angle here with K, there's that big angle K. So we have to use our 3 variables. Do that real quick. Tell me what you think you're going to name that. Make sure we have that before I just throw it down here. All right, and Ahmed, what would you call that big angle? Good. So he said J, K what? Okay. Maybe you said M, but yeah, JKL. So JKL is that big angle. If we then go to LKH, so just follow those letters. LKH, I'm going to erase a little bit here. This you definitely wouldn't have talked about last year, but it's what we just quizzed on. So here's LKH. So that's this angle right here is congruent to what angle? And this one's a little sneakier. As a little hint, this is absolutely what you quizzed on Friday. All right, Cam, before I mark it up too much, what do you think? Okay. Not quite. So you're saying this one right here? Yeah. Okay, not that one. Ella, what do you think? She says J, L, okay, not quite. We want them to be congruent. What you guys are giving me are consecutive angles, like right next to it. So go to where we talk about angles being congruent. So these guys here, actually, we don't want to go to those. What were you going to say, Ahmed? Somebody else popped in. So he says J, K, H. So this guy, not that one. It's all right. Yeah, I know. Someone is beeping in right now. I'm trying to get my eraser to work. I'm going to go to the computer. I've had a couple beeps. Who is this right here? I got Alexandra. What do you think, Alexandra? She said LHJ. We're getting warmer. We're getting warmer. So LHJ would be up here. So we're warmer. So if I had this full angle, then yes, it would be this full angle right here. But we don't have that full angle. We only have a partial amount of that angle. So it's not quite that one. Let me give you this hint now. This is what I was starting to draw in, and this is what I said we quizzed on Friday. Aren't these parallel sides? And remember how we would have all those parallel lines on your quiz and everything we've done here this last week? And then we have a third line that cuts through them. Isn't this angle here an alternate interior angle to this angle right here? Remember all those guys, alternate interior, same side interior, all that good stuff? So this angle is congruent to this angle because they are alternate interior angles. So that we would call, there's a few different ways you can call this. J, H, M would be okay. You could call it J, H, K. All of those would be okay. So a little sneaky on our part to throw in one that's not one of those 5 properties. But again, it's all our old stuff that we have to remember. Okay. But good. I'm glad we threw some of that out there. Okay. So we can at least look and see sort of what works and what doesn't. All right. Number 5. Much nicer. Do number 5 now. Find segment MK. So let me clear some of this up. So find segment MK. And tell me what that would have to be congruent to. This, no tricks here. This is one of the 5 things listed above. So use one of the 5 properties that's listed above these sets of problems. All right. Hopefully a little bit nicer now. So now we're talking about diagonals, right? These are some part of our diagonal. So we want to go up to the top here and look. It's number 5. Diagonals bisect each other. So what that would mean is this point M is the midpoint for both of our diagonals. All right, that cuts both of them in half. So MK, this segment, would have to be congruent to that segment there, because that big diagonal H to K would have been cut right in half. So HM would have to be congruent to MK. Do we get that one, Mr. Kubitz? No. Okay. All right, 6. Let's see here. K, J. All right. Now do this one. Let's see what we think. So find KJL. I'll draw it in so we can kind of see it. Since yours might be getting a little messy at this point, not quite as easy to erase as mine. So K, J, L. So we're talking about this angle right here. All right, we had some brave souls last time. We talked about angles. Anybody want to be brave again? Step out on a ledge. What do we think? Ahmed, what do you think? He said LHJ. So LHJ, this guy? Why do you think that? So see this guy here? The angle that it's going to be congruent to is this one because of the opposite angles in a parallelogram. So this big angle H would be congruent to that one. Okay, so not quite. Let me change the colors so it's a little easier to see. I can get my eraser to work. All right, so again, it's a parallelogram. So that means that this side here is parallel to this side here. All right, Alexandra, did we learn from our last one? What do you think, Alexandra? There we go. Good job. J, L, H. So let me finish drawing this in color. Why did you think that, Alexandra? Okay. Do you remember the theorem, what we said last time? What it was called? Because that's all true, what you said. Here's our... All right. So here's our parallel lines, right? And then we have our transversal. So like that previous problem, aren't these two angles here, the one that we're concerned about and the one Alexandra gave us, aren't those alternate interior angles? And alternate interior angles have to be congruent. So that has to be JLH or HLJ. You can name it that way also. All right, good, Alexandra. All right, last one. Go ahead and give it a go. These are obviously making us think a little bit. That's all right on a Monday morning. Right? Yeah, and just remember my day last Wednesday when I was fumbling around. So nobody's perfect. Why won't this erase for me? So this one now, find angle HLK, that's 82 degrees, and then find the measure of angle LHJ. Come on, erase. There we go. All right, so HLK, so here's HLK. So that's the big angle. That is an 82 degree angle, right in there. And the question is LHJ. So LHJ is this big angle up here. How's this one looking, Mr. Kubwitz? Better? Yeah. Okay. Cam, what do you got, Cam? Good. Good. So, oops, 82. So what he said, subtract 82 from 180. You probably couldn't hear him. And he said because they are consecutive angles. So what that's dealing with is number 4 right here. Consecutive angles are supplementary. So if we know this big angle down here is 82, this has to be 180 minus 82. What'd you get, Cam? 98. So that should be 98 degrees. All right. All right, so it's clear we're not going to get all these done. Let me do this real quick. You're going to add a number 8. We'll call it 7. Is there a number 8 right below this? Probably, yeah. So let's call this 7B. So add a 7B. And let me clear my picture. I'm going to give you a different angle, and I want you to tell me what degree measure it is. So let me clear this off. So 7B. Let's say I tell you that angle, let's do LHK. Come on, you. So LHK is equal to, so LHK equal to, what is that? We'll say that's 65 degrees. That means the angle of HKJ would equal what? Okay. As a hint, the answer is not 115 degrees. All right, Ahmed, you raised your hand very quickly there when I said that. What do you think? We're getting warmer. I like the answer. Here's our parallel lines. So he said it's 65. He is correct. So here's parallel lines. We have alternate interior angles right here. That's our transversal. So what I gave you is LHK is 65. So again, if this is the inside, this angle is an alternate interior angle to this angle, and that happens to be the angle that I'm asking for. And alternate interior angles have to be congruent. So this angle here has to be 65 degrees. If I could write it, I would. My pen's not letting me do it, but that's our answer. All right. You can't forget about all that stuff, can you? That's why I'm saying. That's why I'm saying we may not have to test on. If we don't have the time to do a test before spring break, we don't need to, because all the old stuff still pops up within the context. So even when you take this next quiz, you're going to need to know all the stuff that we've already talked about. Okay? You know, it's Monday. All right. So what we normally do is I do them with numbers, and then now we kind of add the algebra element to this. These are going to be easier, I think. I think we'll get 8 and 9 done without a huge problem, and we'll probably call it a day. So find the value of each variable. So understand, most of these require some sort of an equation that we've been doing over and over again for the last couple of weeks within this module. We obviously don't want to be setting up equations that have different variables. So when you see a couple expressions with y's and a couple expressions with x's, we probably don't want to be mixing those. So when we look at this one, if I want you to solve for x, one of our most basic properties of a parallelogram is the idea that opposite sides, so this side here, has to be congruent to this side here. Notice how those both have the same variables. So there's nothing tricky about this. We're just taking that 7x minus 4 expression. It has to be equivalent to the 4x plus 5. And then from there, we just go through, solve this. So we get 3x minus a 4 equals a 5. Add your 4 over, and then nicely we get an x value of 3. Nothing really different with your y's, right? The y expressions are opposite sides of each other. In a parallelogram, we know our opposite sides have to be congruent. So now I take this expression, this line segment, and this line segment. Those have to be congruent. Those both happen to be the same variables, so we can set those equal to each other and then just solve that equation, and then you're going to get your y. All right, so we'll subtract our 3y. And then just keep solving that. So 2y equals 20. And we get our y value to be a 10. Number 9, hopefully nice as well. Understand what kind of angles these are. It's a parallelogram. We have two different properties that deal with angles. Are those consecutive angles or are those opposite angles? Consecutive angles are supplementary. Opposite angles are congruent. So same decisions you were making a lot on that quiz. Are we adding those up, setting them equal to 180, or are you setting them equal to each other? So as we look, you want to ask yourself, is this angle here and this angle here, are those consecutive or are they opposite? Okay, opposite, someone said in here. So since those are opposite angles, if we look up at the top, our opposite angles are congruent. Those have the same exact variable. They're both x's. So we can go ahead, set those equal to each other, solve that for x. All right. And we, again, pretty efficient at solving these, I would hope. X would have to equal a 2. Okay, last one. Finish the day off here. Number 10. So look at these two angles. Those are angles. And then you're just asking yourself, all right, is this angle and this angle, is that a pair of consecutive angles or is that a pair of opposite angles? Opposite angles are congruent. Consecutive angles are supplementary. All right, so for this equation, do we want to be adding those or do we want to be setting those equal to each other? Adding them? Yeah, good. Because these are what kind of angles, Cam?
I forgot the name.
Consecutive. These are consecutive angles. Consecutive angles are supplementary. That means we want to add those up. In this case, set them equal to 180. So just know the difference between 9 and 10, right? Number 9, we set them equal because those were opposite. If they're consecutive, then you're adding them up, setting them equal to 180. Okay, so hopefully we did that. If you did, hopefully you're on your way to solving this. So we get what, 10x? Uh-oh. This is everybody's worst nightmare, right? You're gonna get a decimal for an answer. Then everybody's like, oh no, this can't be right. It's a decimal. But you should get 16.5. All right. If you got that, then you did it correctly. Okay. All right. With that, we got less than 2 minutes. We'll do this next page tomorrow. There's more properties involved. These get even a little trickier than the first page. So we'll finish these off tomorrow, and then we'll give homework for tomorrow night. All right. All right. Try to keep all this straight. There's a lot here, and we continue to add things. So do your best. And if you have any questions, check in. If you need to make up the quiz, you can't do it this second period, but if you can try to get in Tuesday, tomorrow morning, second period, that would be great so we can share this out with everybody. All right. Yes, sir, Sally. I'd like you to do it in second period, yeah. Yep, that'd be good. From the day before? From Friday? Yeah, it's closed. So you'll just need to email it. Yeah, just email it to me directly. Oh. Then what's... You don't have homework tonight. I put it for tonight, but I'm going to have to change it because we didn't get through everything that I wanted to get through. So you don't have any homework for tonight. That is going to be due to the following day. Okay? Okay, no problem. All right. A lot of angles going on in there. Yep. In an old traditional geometry course, you wouldn't believe how many things you had to remember. The integrated math stuff has really pulled out a lot of geometry, so it's not quite as crazy.
16 to 17 year old integrated math.
Bye, girls. Have a good day.
Because before that, they used to be like doing actual math, like algebra, geometry, integrated.
Yeah, it's interesting to me. I'm not sure which one I like best at this point. See you, Cam. Have a good day.